Today we're talking about section 6.2 and we're going to be focusing on the law of cosines. You can see we have a picture drawn here with the law of cosines listed in 3 different ways. Now, don't get too hung up on the formulas and trying to remember them. You start with a side length squared. Now, the side length you're squaring is going to match the angle that you take the cosine of later. The other 2 side lengths get squared and added together and times by the 2. So you'll notice in each one, the side length matches what you take the cosine of, and then the formula fits the same for the other 2. Okay. And so that's just one way to kind of help you try to remember these formulas. Now, we're going to use the law of cosines when we have a situation of either a side, an angle in between, and another side, or when we're given 3 sides and we have to find the missing angles. Now, when you're given 3 sides and you have to find the missing angles, it's going to be important to find the bigger angle first. And we'll go through an example of how to do that in a couple minutes. Let's go ahead and take a look at our first example. Now, previously we solved these triangles using the law of sines. And if we try to match up the law of sines, we don't really have any way to do that. We have 60 degrees, and that matches with a side we don't know. We have no other way to find these missing angles with their side lengths. So you can see that the law of sines isn't going to work here. And that's why we're going to have to instead use the law of cosines. Now, we're supposed to solve the triangle, so we have to find all the missing angles and all the missing side lengths. I'm going to start by noticing that we have the 60-degree angle. So that's what I'm going to take the cosine of at the end. Remember, in the formulas, if we go back for a second, that the cosine of the angle, so if it's cosine of 60, I'm going to want to use the side across from it to start. So let's go ahead and bring up our formulas just for a minute. So we have the 60-degree angle. Now the side across from it is the side that I don't know. There we go. So we're going to start by saying a squared equals. Now we're going to do the other 2 sides squared. B squared, 20 squared plus C squared, minus 2 times 20 times 30, times the cosine of 60 degrees. Okay, and so that's just using the formula. I'm going to do a little simplifying here. I'm going to square 20 and 30. I'm going to multiply 2 times 20 times 30. Remember, we have to be careful with our order of operations. 400 and 900 is 1,300 minus 1,200 times the cosine of 60. I'm going to grab my calculator right now and do 1,300 minus 1,200 times the cosine of 60, and I get 700, and now I have to take the square root. So side A is going to be 26.5. Now, we're supposed to solve the triangle. I have all the side lengths. The thing I'm missing now are my angles. Now that I know that angle A matches with 26.5, I can use the law of sines now to find my other angles. So let's start with angle B. So we'll say sine of 60. So we're going to go back now and use our law of sines. Sine of 60 equals, sine of 60 over 26.5 equals sine of B over 20. So the sine of B equals 20 times the sine of 60 all over 26.5. When I use my calculator, that's 0.654. And remember now I have to do the sine inverse to get what angle B equals. When I do that, angle B ends up being 41 degrees. If I take 180 minus 41 and minus the 60 we were already given, we come up with angle C in the end to be 79 degrees. And so there are my solutions to the triangle. The only problem is we didn't look for a second possibility for angle B. If I take 180 minus 41 degrees, I get 139 degrees. Now, 139 and the 60 I already know is more than 180. So in this case, we don't have a second set of answers. We only have one answer. You can see we used the law of cosines to find a missing side. Then we were able to go back and use the law of sines. Let's go ahead and take a look at another example. Solve triangle ABC if A equals 6, B equals 9, and C equals 4. So here is an example of side, 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 where we're given the three sides. The first thing we'd want to do is draw a picture. So A, B, C. Across from A, I'm going to put a 6, across from B, a 9, and across from C, a 4. Now, remember I said in the beginning that you're going to want to start when side, side, side happens with the biggest angle. Now, in a triangle, the biggest angle is always across from the biggest side. So we're going to want to start with angle B. Okay? We're going to want to start with the biggest angle. So now, we'll go ahead and set up our law of cosines here, starting with the side length across from B, so B squared, so we'll have 9 squared. Equals, now we add the squares of the other two sides, A squared plus C squared. Minus 2 times those, times the cosine of angle B, because remember angle B matches with the side we started with. Now, don't grab your calculator right away. Do as much simplifying as you can by hand first, because you'll be less likely to make a mistake. So I squared the 9 and got 81. I squared the 6 and got 36. Squared the 4 and multiplied. I'm going to add 36 and 16 together, and I get 52. Minus 48 cosine of B. And remember, I'm trying to get the cosine of B alone. So we're going to have to subtract 52 from both sides. And divide by negative 48. Now, when I do the cosine inverse, remember, even though I want the answer to be negative, I'm going to start by doing the cosine inverse of the positive and get the quadrant 1 answer. When I do that, I get the quadrant 1 answer to be 53 degrees when I round to the nearest degree. But cosine is negative in quadrants 2 and 3. If I take 180 minus 53, I get 127 degrees. That's going to be the angle I want for angle B. If I add that to 180, I'm going to get the other solution. Now, we don't have to bother because right then I'm going to have more than 180 degrees, and I can't make a triangle with that angle. So we now know we only have to worry about one angle, 127 degrees. Now that I know that one, I can go ahead and set up the law of sines to find one of the other ones. And we can pick whichever one we want to find next. Let's just go ahead and find angle A next. So sine of A equals, sine of A over 6 equals the sine of 127 over 9. So you can go ahead and finish this one off on your own as I finish it. When you do 6 times sine of 127 over 9, you should get about 0.531. And now we'll take the inverse to get 32 degrees. So that's the measure of angle A. Now, if I subtract that from 180, I get 147 degrees. But since angle B is 127, that one's going to be too much. The last thing that I need is the measure of angle C. So I'm going to take 180 degrees and subtract my 127 and my 32. And I end up with 21 degrees. And there's my final solution. So you can see, if we go back just for a minute and look through what we did. We started with the law of cosines to find angle B. Then we went back and we used our law of sines to find angle A. Remember, when you do the inverse, you always do the inverse of the positive and then use that to find the other quadrants. Let's take a look at one more example. 2 airplanes leave an airport at the same time on different one-ways. One flies at a bearing of north 66 degrees west. So if this is my first airplane, he goes north and then west at a total of 66 degrees. The other plane flies south and then 26 degrees west. So he goes south and then west 26 degrees. How far apart will they be after 2 hours? So we want to know how far apart they'll be. Now we're missing a little bit more information. The first plane flew 325 miles per hour, and since we went for 2 hours, he went a total of 650 miles. The other one was going 300 miles per hour, so in 2 hours we went 600 miles. Now, I know 2 sides. I'm trying to find the third side. It looks like I'm going to need at least one angle in order to do this. Now, I know a straight line makes 180 degrees, so if I take 180 and subtract 66 and 26, I know that the leftovers is 88 degrees. So I'm going to put that 88 degrees on the inside there. But now, I'm trying to find this side. It matches with 88 degrees. And I know the other two side lengths. So it looks like I have a nice setup for the law of cosines. I'm going to start with the x squared equals, remember then we square the other two sides, minus, we times them by 2, let's go ahead and make a little bit more room here. Times the cosine of the angle, 88 degrees. I'm going to let you go ahead and use your calculator to try to find the answer to this question, and we'll start class with going over this tomorrow.